We have been making wireless happen for as long as we can remember, and we always will. We are specialists who love our work, experts in our field. We take great pride in what we make and what it means to people. We hone our skills, refine our craft, and master the art of engineering. We are passionate about innovation and creating the best product that we can deliver. We forge, we learn, we build, and we grow beyond. It's more than just our vision and mission. It's our passion. We are Poynting, and we will take you beyond a connected life.
Okay. So how many people do we have now?
Already 39, I see.
Oh,
Let's give them, it's only 3 past. Let's give them 2 more minutes and then we can start 5 past 2.
but let me just say that I'm Dora from Poynting Antennas, and I would like to welcome you all. Over the next hour, we will be exploring key insights into multi-career domains, connectivity, and management solutions. In partnership, of course, with DRoam. DRoam is a leading provider of local roaming and satellite connectivity and connectivity management solutions. Today, we will hear from Birger, our wireless connectivity expert at Poynting Antennas, and Guy, the co-founder of DRoam. So, 1 more minute and let's start. As an introduction, I would like to highlight the critical role that antennas play in multi-career domains. Ensuring the right antenna setup can significantly enhance connectivity and performance. But to speak about it, we have Birger. Birger, let's explore this a little bit further.
Yes, I will take over. I will start sharing my screen. You should see my screen now. Yes. Are we okay with the screen?
Not yet.
You see my slide?
No.
That is strange.
Try again.
Screen 1, screen 2. Didn't change.
Yes, now it works. We are seeing your notes. Please do the changing and...
Do you see the slide or the notes?
No, now it's okay. You can
Now
start.
it's okay. Okay, let's start then. Okay, welcome. Of course, you can already see on the title of the slideshow on the webinar, unlocking the power of multi-carrier connectivity. And that's, of course, something where Guy and from DRoam will really go into a little bit more in depth than I am. Now, welcome to this webinar on creating reliable connectivity. We'll address some key factors playing a role in establishing the best possible wireless backbone in 4G, 5G deployments. The questions can be asked via the Q&A and will be answered at the end of my presentation. And of course, after Guy's presentation, you will again have a new opportunity to ask about the SIM cards. So, a little summary. Today we'll talk about what does a connectivity setup look like? How does the infrastructure work? I'm talking about the cell towers, of course. How can we influence that infrastructure? And explain by relevant use cases. So it will be really clear for you to understand what we're saying. The webinar will be done in 2 parts. As said, first the pointing part, emphasizing on the importance of the antenna, and one by DRoam, by Guy of DRoam, emphasizing on the importance of the SIM card technology. So let us look closer at a 4G, 5G connectivity setup. It exists of 3 critical parts. Most of you will start with the router. Features, of course, to see how many LAN ports, does it need Wi-Fi, does it need TPS, does it need VPN or whatever. So that's the first thing you'll look at. And then most of people tend to forget that the router needs a proper signal to work with. If not, you can buy the most expensive 5G router in the world, it will not perform as you want. And what people most of the time do not know is that the antenna and the SIM card play the most critical role in connecting the router or device to the cell tower. It's a similar thing with the smartphone, for example. On getting the best possible signal out there, the antenna plays the most crucial role, as you can easily compare it to the ears of the brain, and of course also the mouth, because a router talks back, uploading back to the cell tower. In essence, the decision is a balance between technical compatibility, signal conditions, network load, and policy rules defined by the mobile operators. There are constant negotiations between cell towers and the connecting device. Does the device hear the cell tower? And does the cell tower understand the device? In both, the antenna plays a critical role. We will see signal parameters like the reference signal received power. It's the signal strength provided by a tower on the location of your application or where you are with your cell phone, for example. A strong signal with congestion or interference will be swapped for a further away tower with a clearer signal. An example, for example, a festival, 80,000 people trying to send WhatsApp text messages or videos or photos. Well, there's no capacity there because there's too much for that one cell tower. Then you have this effect, congestion. A tower offloads devices. If it sees I don't have the available bandwidth for this device, I will offload it to maybe a better positioned cell tower, having more available bandwidth at that moment. Prioritization, emergency vehicles, for example. This is a thing on the SIM card. Handover algorithms within the same operator's network. The router and antenna need to work on the given frequency, of course. And no SIM card, no connection, because a network needs to authorize a device, and it does it via the SIM card. Now, the cell tower infrastructure is there. You cannot move it. These are fixed cell towers. It won't change. But if you try to understand how it works, you can influence it in a positive way. Now, testing in real life situations is not that easy, and most people use a speed test for this. Speed tests are not that accurate, and have a good idea, these need to be performed on different times of the day and over a longer period to really compare it. We will always advise to look at signal parameters. They give you quite some information on the signal level, RSRP, as said, the power of the signal you receive on the location of your application. And of course, the quality of that signal. And this is something you can find in the RSRQ, quality and signal to noise ratio, the SINR. The tools I personally, for example, use are on the top left. This is a snapshot from cellmapper.net. It shows you the towers of an operator in a certain region. Yeah, you type in the address, you type in your SIM card provider, and you would get an idea on which cell towers are in my region. And it also shows the frequencies that are used by these cell towers. For example, in rural areas, you will often see only band 20, 800 megahertz, as these penetrate further through the air. Lower frequencies have longer wavelengths and thus longer antenna elements. Bigger antennas will perform better. In cities, you will see the higher frequency bands, band 1, band 3, band 7. On the bottom left, you have a reference value table for signal parameters. If you want to know, hey, the things I see on my smartphone or I see on my user interface of the router, are these acceptable or not? You can compare them to the table you can find on our website. The top middle, this is a user interface from a router where you can clearly see the signal parameters. Are they okay or not? On the bottom, this easy tool, it's not the most accurate and professional, but you can use it on your smartphone. You just type in where you type in the number you want to call, you type in this code, and it gives you signal parameters on your smartphone from the SIM card you're using. It would give you quite a good idea. I just tested it 15 minutes ago, and it's incredible when you go outside your house, the difference in signal parameters. So I would advise anybody to try it. On the right, of course, you have this professional sniper device. This can really test all signal parameters on different SIM operators at the same time. So it's an easy professional tool, do some pre-site investigation. Now you might be wondering why I help you making the choice on which antenna or which operator SIM card to use. Well, let's go over the things you know, what you can try to find out, but what you cannot control. So, of course, we can give the router more ears. The antennas are the ears and the mouth of the router. So we can go for a 5G router, which gives it four ears, while a 4G router only has 2 ears. And you also have TISO 4G routers with only one antenna, with only 1 ear. Here you can already make a choice and influence your connectivity. So this equation is quite important, and I won't bore you with it, but when you look at it, it really emphasizes on the importance of the antenna. And why? It says that the total capacity of the wireless link equals the amount of channels being created between cell tower and the receiving device, a smartphone or a router, times the available bandwidth given by the tower, and of course also the limits of the bandwidth of the router, and the logarithmic of 1 plus the signal to noise ratio. And again, signal to noise ratio is something you can really influence by using a good quality antenna. Together with the amount of channels, it's introducing MIMO, 4x4 MIMO, 4G, 5G routers, cross-polarization technologies, so you can increase the number of channels for the reliability. So it all adds up to a better connectivity, wireless connectivity. So what sets us apart? We don't make antennas, we shape radiation patterns. And the radiation patterns, I will come back to that, is really what defines an antenna. What you see is what you get. Our technical documents show real measured results, not simulated, or a lot of them don't show them. Quality materials are being used to create long-lasting antennas, no matter what the conditions are. And Poynting antennas hold over 70 patented antenna electronic designs, which makes it hard to copy for competitors. Wherever possible dimensions give us the possibility, we try to implement RF technologies like cross-polarization, but that's more for in-depth. So, built to last and quality by design, cross-polarization. I forgot to click the button, it's obvious. So, what makes a good quality antenna? I won't have time to go through all these different characteristics today, but I just want to highlight a few. Most people will understand the first one, which technology, 4G, 5G, and have a notion that gain says something about the performance of the antenna. This is where we try to make sure people will look a little bit further into the technical document when available, as gain is so often misused as a marketing tool. We don't make antennas, as said. We shape radiation patterns since 30 years now. So the radiation pattern is really what defines the antenna and will give you really the idea on how this antenna will perform for your application and if it's even suitable for your application. So, So, looking closer into a very neat example here, you would see a similar spec antenna on the left and the right. And the words of our boss, of our CEO, are always, the better spec antenna is probably not the best one. And this is a clear example because we're looking at an omnidirectional antenna. Yeah. And here again, it's higher spec than on the right, the Poynting antenna. But it's again misused or has been measured in a useless direction, that gain. So if you buy an omnidirectional antenna with a certain max gain, you expect it to, of course, have this maximum gain in 360 degrees around the antenna, around your application. So however you install it, it will perform according to what you bought, the 5 dBIs. Now, nothing is further from the truth. The truth. In the slide, you see a so-called higher gain quality antenna. You see, but when you look at the radiation pattern, it shows nowhere the promised 5 dBi. That means that 5 dBi was not measured, if it's been measured, was not measured in 360 degrees. It's probably somewhere else, maybe shooting to the moon where there are no cell towers. And you also see very big variations in gain, differences from 14 dBi, for example, and then knowing that 3 dBi, a loss of 3 dBi is already reducing the signal to half of the power, and it's logarithmic, so it really increases fast. Now, the pointing antenna on the right shows less max gain, but very evenly 360 degrees spread of the gain, really nearing the promised max gain of 3 dBi. However it's installed, you're sure that 3 dBi is there, or if installed on a vehicle, no matter how it turns compared to the cell tower, it will still give you that promised gain that you see in the title, and in a very omnidirectional way. So how can we maybe make it clearer? We will make clear that focusing on these radiation patterns and why consistent omnidirectional antennas are so important. You will notice during the discussion of the use cases that all the tricks and tips I gave you on pre-site research, the RSRP investigation, the RSRQ signal to noise, well, to be honest, it's not possible, or it's just too much work, because we're talking about multi-site deployments, thousands of deployments in a region, in a country. So you don't just have the time to do this pre-site research. It might give you an idea when you need to troubleshoot. Mobility, of course, when something is mobile, a fleet of buses, a fleet of logistics vans, well, they move, they constantly change their position compared to the cell tower infrastructure. And of course, maritime vessels, they sail all over the world, all over continents, so they constantly change their position compared to the cell tower. And this is where a good omnidirectional, with a superior omnidirectional radiation pattern really shows off. So a very known IoT case, of course, EV chargers, or even those mobile watchtowers you see more and more to protect, for example, big construction yards at night, so they won't steal the materials, the high value materials on the construction sites. You see these more and more. And of course, people always say, hey, EV charge, it needs to be a low profile antenna, it needs to be vandal proof, it needs to be UV resistant, waterproof antennas. It's seldom they first start talking about, hey, how does it perform, your antenna? So it's always a compromise. Now, our puck antennas are ideal for this. And most of the time they're chosen after, whenever there's a POC, a proof of concept, we are chosen. Because to be honest, we are not the cheapest puck-like antennas out there, but we really stand out in POCs, where we really show performance, and that's the most important thing. Because why? These things are manufactured in the factory, so the EV charger comes out, and then the guys manufacturing the EV charger, they don't know where they will install it. So it needs to work in all different conditions, in all sites in a country or in a region. The same with these mobile watchtowers. They are being leased or loaned to a construction yard. So wherever that construction yard is, there it needs to perform. That's why a quality antenna needs to be on there to secure that reliable connectivity. And of course, the left one, it's CCTV cameras, etc., bigger data. So you would go for a 4x4 MIMO antenna, 5G. And on the puck, on the EV chargers, more small data that needs to be transferred. So there, a puck is most of the time the chosen one. So another very nice use case, solar farms. You see these more and more because it's a very ecological path forward for the future of our planet. So we are all fan of it. But where are these installed? Where you have room to install that? In more remote rural areas. It is good to know that their operators always use these lower frequency bands because they penetrate much further in through the country. So in the 4G, the coverage band would be 800 megahertz. In the 5G, that will be 700 megahertz. So then just going for that max gain you see on the title, the Omni 293 great antenna, 9 dBi of max gain. Well, that max gain is in the higher frequencies. So you really need to consider, what do I still have on gain on these lower frequencies? And this is okay for the Omni 293, where you would need a puck. A puck would have much less performance on those lower frequencies because it's much smaller, and longer antennas perform much better on lower frequencies. It's a simple physical fact. So mobility, There's a lot of different vehicles out there. You have bus fleets, you have ambulances, you have logistics vans. So there can be a lot of difference on needed bandwidth. Where do they drive? Is it in rural areas or is it really in city areas? So this is where the different types of antennas play their role. I always say the bigger the antenna, the better they will perform remote and in rural areas. The puck is always say the city antenna, the MIMO 4, the MIMO 3 are bigger. And then we recently had launched a new Swirl 8 antenna, which is, for example, ideal for dual 5G use for high bandwidth availability, but works in city really good, works remote really good because of the higher size antennas inside. So depending on where you are, and they all share a common value. They have great omnidirectional radiation patterns. So no, however that vehicle is positioned compared to the cell towers, it will always be inside and it will give you good, reliable connectivity. Because the more cell towers you see, the more you influence the good decision of the cell tower infrastructure. So for people who know or in the maritime business, we all know this as a screenshot from marine traffic. This shows you a little bit on how many vessels there are sailing around the world. Different colors, different types of vessels, fishing vessels, commercial fleets, tankers, whatever is out there. So you see these move around the world, around regions, around continents. So for them, a good, superior omnidirectional antenna will, of course, make the difference in having 4G or not, or having much more signal, much more bandwidth for the crew welfare, for the reliability in the total hybrid connectivity setup, which is at the moment more like Starlink 4G, 5G. So it's knowing how to optimize this connectivity. And from the 4G, 5G point of view, we have been really acing this. In 3 years, we have been introducing new dome antennas where you can really optimize everything. And what it does is it's really clear when you have like this vessel, yeah, and you see the towers on land, a poor omnidirectional antenna will give you, yeah, three antennas. Yeah, the other ones are not really good inside that thing because it's not really clear and omnidirectional. So we will have less reliable connectivity, less bandwidth, less good signal, and then even when the ship turns and changes direction, it could get worse, sometimes better if you're in a better part of the antenna, but it's not trustworthy. You don't want that. So if you put on a good quality antenna, this is what we do in Poynting, the superior omnidirectionality, it would really make a difference because then you would have like close to a circle. So you would see much more cell towers. So you would give much more influence to the cell tower infrastructure to really make their choice on which cell tower would give the best signal to the router on board on that vessel. You just give more choice. It's like winning the lottery. Your chance will increase when you buy more tickets than if you only have one ticket. So better omnidirectional antenna will give you more throughput capacity, more reliability, more coverage, and much more uptime, meaning much more time on 4G on connection. So these last years, we have been on the forefront of the evolution in 4G, 5G maritime connectivity, for example. It's like really optimizing everything we know from the maritime. So reducing long coaxial cable lengths, putting the routers really inside the domes that protect the router. The only thing that comes out is an internet cable, so really flexible up to 100 meters, no loss. There are, of course, different parameters here on distance, Swirl 8, Ripple, and Wave Hunter, 40 kilometers, 70 kilometers, up to 100 kilometers. And of course, the use of multiple 5G modems inside, 1 to 2 for the Swirl, 2 to 4 for the Ripple, and the Wave Hunter can even go up to six 5G modems inside. And because of the dimensions, also having horizontal dimensions compared to the older stick antennas you see on the left, because of having this horizontal dimension, we were able to of course, introduce a very efficient technology called cross-polarization, which will even guarantee you double the bandwidth out at sea compared to a normal stick antenna. And that's where we really ace this segment of the industry. So here you see them in real life on vessels to give you maybe an idea on the dimensions. So you see the Swirl is the smallest one. Ripple 8 is a little bit bigger. It's about, in height, double the size, let's say, as a Swirl, maybe a little bit bigger. And then the Wavehunter is really the big one. This is really used on big vessels, offshore vessels, building offshore wind farms where 200 people on board are working continuously. So these people want internet like home. And the container vessels and the tankers are more into Ripple. And depending on the sailing route, of course, how far offshore are they sailing? Because more vessels are within 4G reach. If they would use a good connectivity, a good antenna solution from Poynting. So again, do me a favor, and I'm emphasizing again on these signal parameters because it gives you such a great NT. If you're able to do pre-site survey, it's awesome. If you're able to do, if you're in trouble and you want to troubleshoot from a distance and see, hey, let's see if there's something with the signal reception or whatever, please go into the router user interface, look at the RSRP signal to noise ratio, the RSRQ, and compare to this table. You can find it for free on our website, and you can really compare it. If you were able to do after the installation of the application, you would do this screenshot from the user interface and you look at RSRP, RSRQ signal to noise. Please do a screenshot, put it in the dossier you put together on the application. And if you're in the orange, to be sure, I would not sleep well because the moment you would have fog, heavy rains, it will impact on the signal levels out there because they just impact and you cannot change that. So it's better to go for yellow of green. So have a good antenna and have a little bit more buffer. So if weather changes, you will still have signal left. So that's one of my tips I can give you on when you leave the site. Please do a check on these signal parameters and then you will be able to sleep at night. Conclusion, the antenna is a crucial part of the connectivity setup. Optimization is a lot of times not possible because of various reasons, mass deployment, etc. So you need antennas with a great radiation pattern you can rely on, you can really trust. A quality omnidirectional antenna can increase flexibility of the installation because a lot of things are made with connectivity inside, but they don't know where they will be installed, or at least vastly reduce the total cost of ownership because saving an antenna might give you a nightmare in the end. Mobile applications can only be secured if the antenna sees the necessary cell towers, regardless of the vehicle's position, of course. The more cell towers you see, the better. Choose an antenna that fits the connectivity challenge, and we're always open to look at it to look at this together. And if you choose a Poynting antenna, to be honest, all these things you can optimize. We already do it for you, so you can sleep on your both ears. We offer Poynting Academy free of charge on our website if you want to know more on basic antenna fundamentals, or if you want to be more in the category mobility, maritime, IoT. There are these different Poynting Academies online, free available for you to follow and to learn more about the antennas. So the next steps with Poynting. I think I am now open for questions if they are there.
Well, this they are a little bit quiet, Birger, but I'm sure they are joining. But we have a question in the chat. If you can just go there. Considering the advancement in the satellite technology, Starlink, in what scenario would you advise a directional antenna?
A directional 4G antenna. Well, to be honest, if you don't have multi-site, if you have time to do some pre-site survey, as I said, and if you really have the time to optimize, even when on-site looking for the best possible signal and really fine-tune a directional antenna, then I think 95% of times you can use directional antenna. But there's just a lack of time, and that's why people I a lot of time have the discussion with people and say, okay, we understand it, but then the installations team, they need to do 20 deployments per day. So they don't have time to fine tune that. Else we could really do a lot of things with the directional antenna. Do not really know what the connection with the Starlink is because it's another technology. But yeah, so I'm not sure if I'm answering your question correctly. Because Starlink is another technology, it's a LEO satellite technology, and we are we are taking the connectivity from the cell towers on land. So, but please fine tune your question. I'm happy to look at it again if it wouldn't have answered your question.
Yes, of course.
Now, after the webinar, after Guy's presentation, of course, on the SIM cards and the intelligence SIM cards that D-Roam provides to its customers, there's more time for questions on the SIM cards and on the antennas. So if there's no other questions, I will give the word to Guy. Please, the stage is yours.
Thanks, Birger. Thank you, Dora. So while turning on my presentation, I have basically one request to the participants. Guys, if you can use the chat, please, and write with how many telecom vendors you are currently working. Like if you're buying all your SIM cards from one telecom, just write one. If you're buying from two, please write 2, 3, and so on. I'll turn my presentation. I just want to hear basically, how many telecom suppliers you have, SIM card suppliers you have. You can use just the chat and write the numbers. Okay, so 4 and 2 and 2 and 1 and 2. Okay, so I see majority basically have more than one telecom provider. Great, because that's exactly what we are going to talk about. And let me know, please, Dora, let me know, please, when you can see my presentation.
Okay.
Yes.
Yeah, everything is okay.
Okay, perfect. Okay, so I want to start from a quick reminder, basically, what SIM card is. I think it's basics, and I just want to make sure that everyone here, basically, we are all on the same page. Okay, so SIM card, unlike many people think, tend to think, it's not a piece of a storage device. And the SIM card, it's not the same as SD card or, USB stick. Indeed, we do have some storage on SIM cards, but SIM card is mostly a chip, basically, that performs only one, but very, very important operation. Okay, and this operation as basically encrypting and decrypting a handshake signal from telecom. I'll try to basically explain it in a simpler way. The moment we take our smartphone and turn it on, this smartphone connects with all the telecoms he can find in his area and sends them some pieces of information. Okay, and one of those pieces of information is basically ICC-ID, which is your SIM card number, let's call it this way. And while doing that, basically all telecoms receive this piece of information. They all receive, okay, there is a new subscriber in the area who wants to connect, who wants to have cellular services. Should we provide him with cellular services or not? So the next step, basically, all those telecoms that receive your ICC-ID or receive your SIM card number, checking their databases and checking if you are the subscriber, okay, of basically of one of them. And obviously, one of those telecoms finds you in the database, if you're lucky, or if you're paying your bills. And the moment they find you in the database, they basically are willing to connect you. But in order to connect you, they need to run some authentication protocol, okay, to make sure that it's really you, that you are not faking it, that it's not a fake, some kind of hacking attack or whatever. And to do that, they basically send some encrypted information, your SIM card, once again, that acts as a microchip, decrypts this information, sends it back decrypted to the telecom, and then telecom knows, okay, this guy is really my subscriber. They're not faking it. They're not a cyber attack. Let's provide them with cellular services. Let's check if they're paying their bills, and if they are paying their bills, we will provide them with the services. So that's how SIM card basically works. And overall, SIM card has 3 major parameters. And not unlike with antennas, in Birger example, when you have a variety and a lot of different settings, in SIM card, you have shape. Okay, SIM card can be big or small or very small, nano, micro, 2FF, 4FF, and yada, yada. SIM card can be physical, like basically like we all know them, plastic SIM cards, or nowadays it can be also virtual. Most of the people probably heard here about eSIM or iSIM. Basically, it's exactly the same SIM card, but physically embedded in a device. Okay, so when you hear eSIM, it's not a completely different SIM card. It's exactly the same, just different form factor. And of course, SIM cards do have some storage space where you can store phone numbers or some other information, and SIM cards can have a different capacity of the storage space. So those are SIM cards. But we are here to talk about multi-carrier connectivity. So why I'm starting basically with SIM cards. And the reason that basically we have many different types of multi-carrier connectivity and multiple ways how we can work with different telecoms. And also many scenarios, okay, and different scenarios where we should know which type of SIM card or which type of multi-carrier connectivity is most suitable for us. And that's basically the goal of my presentation today, to share our experience of working with multiple telecoms using different technologies. I would like to start with the first technology. You have probably heard about it. It's called multi-IMSI SIM card. So what is multi-IMSI SIM card? As mentioned, every SIM card is basically connected or issued or provided by a specific telecom, okay? And only this telecom can use the SIM card, can connect to the SIM card, and can collaborate with the SIM card. And this, basically, this piece of information which stores the ID of telecom that can connect to the SIM card, called IMSI. We had it in the previous slide, basically International Mobile Subscriber Identity. It means the ID of the telecom that has the permission to speak with the SIM card, okay? So I would say approximately 10 years ago, even maybe a little more, a new technology emerged called multi-IMSI. What is multi-IMSI? Basically, you can think about it as many SIM cards that you just glue together. Okay, it's physically one SIM card, but this SIM card is capable of storing multiple IMSIs. Okay, or in other words, many different telecoms can connect to the SIM card. Not simultaneously though. Okay, so this SIM card can be for one day, basically, it can belong to one telecom, and the next day it can use another IMSI and can belong to another telecom. Okay, and this technology might be useful in some cases, and this technology has different cons and pros. Okay, and that's basically what I wanted to talk about. So, what are the advantages of working with multiple IMSI SIM cards? Yeah, with SIM cards that have many telecoms that are capable of connecting to it and collaborating with the SIM card. So first advantage is basically cheaper. Okay, it's pretty cheap because in some cases it's kind of local SIM card. That's one. Second advantage is redundancy. Okay, and redundancy can be very crucial in some industries. And by redundancy, I mean that if there is an outage in Spain, for example, and Telefonica is not providing their signal, but you have multi-IMSI SIM card that works both with Telefonica and, for example, Vodafone Spain. In that specific case, the SIM card can do a follower to Vodafone and connect to you via Vodafone. So though you had an outage yesterday, as I know, and apparently you had the single IMSI SIM, not multi-IMSI SIM, right? That's probably the reason why we are not able to connect yesterday.
Yeah.
But redundancy, as you can see from your personal experience now, can be very important in some cases. And in some industry, we will get to that a bit later. Another advantage of multi-IMSI SIM is that it can be frequently used for permanent roaming. Once again, why? Because sometimes you can store multiple local IMSI profiles, okay? You can have a local profile, like home profile of Telefonica for Spain, and of O2 for UK, and for Odido for Netherlands. And then you can use the same SIM in all three countries. Every time it will be connected with the local profile, basically providing you with local connectivity, and the telecoms will not see that this is a multi-IMSI SIM. They will know that, and they will see only local profile. So if you bring the SIM card to Netherlands and turn it on in Netherlands, Odido will see a local user. So for them, it's not a roaming SIM card, so permanent roaming is enabled in this case. Same goes for local breakdown and lower basically latencies. Okay, because this is just a local SIM card in every country you turn it on. Okay. But what are the disadvantages of multi-IMSI SIM cards? Okay, and unfortunately, this SIM card is not ideal. So the first and biggest disadvantage is basically the switching algorithm. There are many companies today that are selling and that basically created multi-IMSI SIM cards. In most of the cases, the switching algorithm, okay, the algorithm that knows how to switch one IMSI to another IMSI is not perfect, okay, and you might have basically issues. I can tell from my personal experience, I had a multi-IMSI SIM when I was traveling from Bulgaria to Greece, and after passing the border, it was a disaster. Restarts did not help. Changing APN manually, enforcing local networks, nothing helped. The SIM just was not able to turn on the Greece IMSI, the Greece profile. So sometimes it might be a big problem. And therefore, when selecting a multi-IMSI SIM for yourself, you have to basically really do a good research about who is the vendor of your multi-IMSI SIM. Okay, some of them have very faulty algorithms. Some of them have pretty good, but that's something to be checked and tested, and depends on your use case. You really have to pay attention on how those IMSIs are switched. And if you need basically high quality, check for references of your vendor and do your own tests. Second, this technology is slowly basically declining and becomes obsolete. Why? Because the new standards of GSMA, okay? And GSMA just last year introduced a new standard which allows remote IMSI provisioning. What is remote IMSI provisioning? Is basically like sending email to the SIM card with IMSI number. And it means that instead of the current multi-IMSI SIMs, they store from day one multiple IMSIs, 5, 7, 3, 10 maximum, okay? The new protocol, the new standards of GSMA allow basically, allow to provision to send new IMSI remotely over the air to the SIM card and then connect with whatever IMSI was sent to the SIM card. It is still not a perfect algorithm. It's still basically under development with many companies, but that's where the technology is heading. And that's where basically most probably existing multi-IMSI SIM card providers will head and focus their efforts and their current technologies and SIM cards. Okay, so if you want to learn more, but once again, you can go to GSMA website and do GSP 32 protocol. And then you will see more about remote EMZ SIM provisioning. Another disadvantage of multi-EMZ SIM card, it's basically being a bit less secure. I'm not saying it's not secure, but they're less secure than local SIM cards or roaming SIM cards, because this switching algorithm, the algorithm that switch EMZs sometimes can be hacked and sometimes can be accessed, and depends where the switching algorithm is and so on. So it's a bit less secure. I'm not saying not secure, but less secure than local or roaming SIM cards. And additional disadvantage of multi-EMZ SIM cards is the voice part. Because you use multiple EMZs and you kind of switch from one telecom to another telecom, you might have your voice call redirected between those telecoms. And one of the effects of this, for example, is your phone number. Raise your hand whoever received basically a phone call from a friend, but it was a different phone number and not usual phone number of your friend when the friend was traveling abroad. Okay, so I guess some of you basically had this experience. So why your friend, when your friend is traveling abroad and the friend calls you, sometimes you can see his SIM number, and sometimes you see a completely different number. Depends on the technology. If they're using roaming technology, you will see his own number. If they're using multi-EMZ technology, most probably the voice and everything will be redirected between telecoms, and you will see a different number, which in some cases might be problematic, and in some cases can be basically a piece of disadvantage. When usually we recommend using multi-EMZ SIM cards, and basically when our customers are using EMZ SIM cards. Mostly in, I would say, static mass deploy international cases with high consumption. This is the most classic scenario. Examples, Birger, just you mentioned EV chargers. Now my turn is to mention EV chargers. Okay, example, EV chargers. In many cases, EV chargers are spread around multiple countries of same company. In many cases, they consume a lot of data. They need basically local breakdown because of the encrypted VPN tunnel and the financial information that goes through EV chargers. So EV chargers, and we are working with some company basically doing those EV chargers. It's a classic example for multi-EMZ SIM card. And another example is IP cameras. Again, they consume a lot of data. In some cases, they do want some private IP. In some cases, you have companies that are doing IP cameras internationally. And basically, it's a very classical use case to use multi-EMZ SIM for IP cameras. Golf courses, well, once again, it's maybe not a very typical customer, but we do have this customer, UKD, and they're doing telemetry and they're doing screens for golf parks around Europe. And, you know, it's screens, they're static on one hand, on the other hand, it's mass deployment, it goes all over Europe. They don't know exactly which terminal will go to what country on one hand, but on the other hand, they know it will consume a lot of data, and basically they want it globally. So more non-typical use case, but yes, golf courses basically use this. Critical infrastructure, which means different security sensors, infrastructural security devices that are sending a lot of information. They're usually local. In many cases, they send a lot of data. In many cases, they need static IPs, private IPNs, some other security related information, and basically multi-IMSI SIM, it's a very good scenario and a very good solution for such industries. OEMs. Why OEMs? Because mostly because of the mass deployment, and they basically need to scale, and they want to be able to scale. And drones, once again, we have also customers from drones industry that are using multi-IMSI drones that can go cross country. They consume a lot of data, so it's multi-IMSI. It's quite a good solution. And once again, please, if you want to deploy multi-IMSI, check who is the vendor, and check and do your own tests, especially when crossing a border. Questions so far before I switch basically to the next type of technology?
Don't think that we have questions for now. Guy, you can continue.
Okay.
Yeah.
Perfect. The next type of technology is basically a roaming SIM card. Okay. Roaming SIM card, it's a SIM card that has only one IMSI. It belongs only to one telecom. But this telecom has roaming agreements with other telecoms around the globe. Meaning, the moment you take the SIM card and going abroad, you will stay basically a subscriber of your original provider, and you will pay bills to the original provider, and your phone number will not change, and your IMSI will not change. But you will be able to roam abroad, basically to use data abroad. And why? Once again, because telecoms have agreements between each other, and in most countries, like there are roaming hubs, and in most countries, telecoms are connecting to each other using this roaming hub. So it's I would say the most the first technology that was here in the market when roaming started and when international use of SIM cards began. What are the advantages of roaming SIM card? First and foremost, it's a very mature and reliable technology. In most cases, if roaming is enabled, it will work. You don't have to change your APN. You don't have to enforce any carriers. It will everything will work automatically. And as mentioned, it's the most mature technology out of all. Roaming in most cases has the highest coverage of all, because once again, the agreements are there, and depends on the bundle, obviously, that you buy. But if you buy a global world bundle with most telecoms, you will have coverage almost anywhere. And yes, and if you want to use voice internationally, roaming SIM cards will give you the best basically quality. They will give you the same number, and it will work in the best way. What are the biggest disadvantages of roaming SIM card? First, they are expensive. And why they're expensive? Because of cost of sales. When you're using your local SIM card, your home telecom basically has no cost of sales. They have antennas in place, they have base stations in place. So if you use 1 gigabyte or 100 gigabyte, they don't really care, unless you abuse or something. But overall, it's not really affecting their infrastructure. It's not really affecting their bottom line. With roaming, every gigabyte, every megabyte matters. Why every gigabyte matters? Because they're basically bilateral agreements. And because for every megabyte that you are using, they have to pay for that megabyte to the hosting network, basically the network that was hosting you. So with roaming cards, you have to pay a lot, and it's very difficult to find a cheap solution, let's say it this way. Second, you usually have high latency, because the HLR, basically the customer's database, located in your home country. So if you live in United Kingdom and you travel to United States, it means basically that the moment you're roaming in United States, every Google search you will do will go to servers in UK, Okay, we'll find results in UK, basically in Google UK, and we'll send you results back to United States. So the latency will be pretty high, and the information, the Google information, Google results that you will see will not be from Google United States. They will be from Google UK, because that's how roaming works. All the database and everything is processed with your home telecom, or you only use the antennas and base stations of the hosting telecom. It's due to those technologies, it's so pretty rare basically to find the roaming SIM card with global static IP and permanent roaming, especially permanent roaming. Again, because of the agreements, in most cases, the agreements say that roaming is not available forever. You can do it just on a temporary basis. And obviously with roaming SIM card, you do not have local breakdown. It's usually breakdown of your home carrier. When do we advise using roaming SIM cards? Basically, if it's pretty low volume and global coverage, for example, GPS trackers, okay, they are using hardly a few megabytes a month, but they are very, very widespread and used in many, many countries. Same goes, for example, for container sensors and other sensors. In many cases, roaming SIM cards are used for travelers, even though travelers are also using multi-IMSI and some other technologies, but the most classical use case is roaming SIM cards for travelers. And overall, low volume global IoT, basically, especially if you need something reliable, we would recommend using roaming SIM cards. Yeah, of course, you have to double check the price, and you have to make sure that it's really low volume and you do not have any exposure to significant amount of usage. Questions so far before we go to next technology? Dora, by the way, for some reason, I do not see the...
No, you can continue. Maybe you need to speed up a little bit, Guy. I know you love to speak about this, and it's so interesting, but...
Okay, sure. The third option to work with multi-telecoms is basically having multiple telecoms, the multiple SIM cards from different local telecoms, and just managing them in a single pane of glass, managing them in one software. This is basically our expertise. That's what we do at DROM, among other things. But there are advantages and disadvantages also with this setup. Basically, once again, what do we mean here? It's basically when you have multiple local SIM cards and just use them, you know, for specific use cases, and manage, but centralizedly managing them. Okay. So what are the advantages? First of all and foremost is the cheapest option. Out of all options is the cheapest because you're working with local telecoms, local SIM cards. And as mentioned, for local SIM cards, your telecoms do not have cost of sales. You can use 10 gigabyte or 1 terabyte, they don't care. It's exactly the same for them. You will have local latency and all the advantages of using local SIM cards like static IPs, VPN tunnels, and everything, you know, related to local SIM cards. Disadvantages of working with many local SIM cards is first and foremost complex to manage, and this is something basically where we help you, and this is a problem that DROM is addressing. With us, you can very easily manage many local and regional and international SIM cards. Same goes for part number 2. Usually it's very difficult to scale because when you have agreements with 3 telecoms and 50 SIM cards with each, you can survive it. But when you have 500 SIM cards with each, it becomes quite a headache. So we are solving this manage and scaling problems with our software, where you can manage many different local SIM cards and regional SIM cards, and even satellite. If somebody will be asking about satellites, yes, you can manage satellite with our software alongside local and regional and global SIM cards. Obviously, disadvantage that local SIM cards cannot travel internationally. They can be used only in one country. And the last disadvantage, we'll talk about it later, they really depends on the statistics, because in most cases, when you are buying local SIM cards, you are buying bundles, not megabytes. And bundles can sound very cheap, but the bottom line, they can be very expensive. We'll talk about it a little bit later. I'm not pausing for questions, moving forward, right, Dora?
Yeah.
So when basically local SIM cards or combination of local SIM cards with global SIM cards are most suitable? Of course, for fixed wireless access use cases, like backup connectivity, like connectivity in rural areas, like temporary connectivity for immigrant parks or the different workers that are coming to work in your country. So all those temporary locations or agro, they basically, you need local SIM cards in those cases, sometimes from different providers and different telecoms. Same goes, of course, for SD-WAN services, which usually a mixture of fiber and satellite and local and regional SIM cards of everything. And of course, cruises. I can tell you that we have multiple maritime customers. Birger, some of them are our shared customers that are using combination of local SIM cards. Why? Because, for example, river cruises, they're going and passing multiple countries. They have connectivity almost all the time because they have very good antennas from Poynting. And they also have very good prices and very low latency because they're using local SIM card that they're buying from us. Okay, and I'm talking not only about river cruises, but also about regional cruises. They consume enormous amount of data, many terabytes. So they really care about the prices, and local bundles is the best option for them. So, you know, with the ability to manage it correctly, good antennas, good connectivity, it's ideal solution for many river and basically maritime sea cruises. Well, there's another technology that is basically started to develop roughly in 2015. And nowadays, you still can find it in the market with some providers like Peplink, for example, if you heard about Fusion SIM from Peplink. But technology called virtual SIM cards. Basically, it works in a very, I would say, straightforward way. You have, in one location, you have a bank of SIM cards, of local SIM cards, like hardware with many local SIM cards in it. And in other location, you have another piece of hardware that knows which local SIM card should be connected at every moment and pulls the correct SIM card from your basically bank of SIM cards. As mentioned, basically the advantage, again, price. Local SIM cards always cheaper than roaming or multi-IMSI. Same goes for latency, and it's possible to scale it pretty good. Biggest disadvantage, it's because you need expensive hardware. It's not cheap. And second, once again, this technology is not perfect. It's really not perfect technology. It works, I would say, so-so, depends on the vendors. And yeah, there are quite a few disadvantages in terms of how this technology works. But as mentioned, basically, let's mention it's still in the market, and companies like Peplink selling it. Two most popular use cases. One is failover, basically in some way backup connectivity, but mass scale backup connectivity when you really need you know, big amount of scalable SIM cards, like you're a corporate with many branches, and you don't want to have many local SIM cards always connected in all those local branches. So you have this kind of virtual SIM cards, and you just pull a local SIM card to a specific branch whenever you need it, like for backup connectivity when you have outage and so on. Apparently in Spain it was not just yesterday, but that's one use case. And second use case also in maritime, in some cases when you have also, you need to scale and you have a lot of hardware and so on. And again, you want to use local SIM cards because you don't want to pay a lot for multi-IMSI or for roaming. So that's basically a virtual SIM card technology. I promised to speak a little bit about cost optimization, and that's basically also what we do with our software. We are doing different statistics, and we are doing different optimizations of using local and regional plans. We are doing some kind of load balancing and switching between different local regional SIM cards. So I did wanted to mention basically two important rules, okay? And in many cases, you might be considering, what should I be using? Should I be using many local SIM cards, or maybe I should be using multi-IMSI or roaming SIM card, or maybe I should be using a combination, and what is my price, and when I will be paying more? So if basically we put aside all the technological and latency and the other use cases we just described, there is one important rule to remember. When you are calculating your price, especially with local SIM cards, first of all, you should look at your annual expense, not monthly expense, okay? And that's one, because 1 month, it's not enough to gather all the statistics, and local bundles are usually dependent on statistics. And you should always remember statistics. And in some cases, you can buy 100 terabyte bundle for 100 euro, and you think, wow, that's such a great price. I kind of pay 1 euro per gigabyte. It's probably very cheap. With roaming SIM card, I'll be paying 3 euro per gigabyte. So local SIM card definitely best option for me. But then you check your statistics, and you see that you use only 25% out of the 100 gigabyte. So actually, you use 25 gigabyte and still pay the 100 gigabyte bundle, 100 euro bundle, sorry. So it means that actually, de facto, you pay for every gigabyte 4 euro and not 1. And therefore, another option, 3 euro per gigabyte with a roaming SIM card, is basically more preferable for you and cheaper for you. Okay, but it's very difficult to say when you're looking into your 1 month's usage. So that's why I'm saying always check your annual statistics or the estimation of your annual statistics. Make sure that overall your usage with local bundles worth it versus price and versus price per megabyte. Okay. Also, do not forget that in many cases with local SIM cards, you do have commitments. You cannot buy SIM cards without an annual commitment or basically 2 years commitment and so on. With multi-IMSI, in many cases, you do not have commitment. Furthermore, you do not pay anything if, sorry, you do not pay anything if the SIM card is not used. You pay 0. And that's super important because even 1 month of local SIM card that is not being used, but you still pay for it, might completely change your financial situation and financial statistics compared basically to a roaming SIM card. So when comparing pay per gigabyte or pay per megabyte SIM cards, multi-IMSI/roaming, and local bundles, always remember statistics, usage statistics of your bundles, and commitments that basically sometimes you want to terminate a commitment, but you cannot, and you still have to pay for it. Okay, that's basically our important piece of advice in terms of basically of using local and combining local and global SIM cards. As mentioned, our software helps you with that, and our company helps you with that, and we can basically and we can show you all the statistics. You can always download it. You can see in real time how much you are using with local SIM cards, with international SIM cards. You can do all those calculations and comparison, and yeah, use our software. Okay, so I have 5 minutes left for questions and answers. If you don't know what to ask or want me to answer, I prepared some of the questions for you, basically.
But if you want to start by the question that we have in the chat.
I don't see the chat for some reason, so I would love to start, but I don't see it.
Dora, maybe I can, because it's not really clear. Mr. Dave Meadows, will your set, so I'm thinking from
Setup?
satellite, work in Canada?
Well,
This is the question.
our software is bring your own telecoms software, which means if you have a vendor who provides you with satellite connectivity, you can always connect this vendor to our software and manage all this connectivity, statistics, bundles, manage your sales, everything using our software together with cellular. But basically, you are very welcome if you have a local Canadian Starlink distributor, just buy from him and connect it to our software, and we will do the rest.
Okay.
Guys, just write down. You have here 5 questions if you want me to answer on one of those or all of them, or something that's basically I will be more than happy to do it.
I think you can do a summary, yeah, answering these questions, Guy, please.
Okay. So just okay, I'll answer the question because there are some important pieces of information here. So first, if you work with many telecoms, you have to know what is steering. Okay, what steering is basically. And steering is a term that is used by describing like what telecom I should select to work with when I am in other country, let's say this way. Okay, so if you're using multi-IMSI, if you're using roaming SIM card and you're going abroad and you have a good antenna from Poynting and then you have reception of all telecoms in the area, somehow you have to select who is the telecom that will be working with you, okay? And the way of selecting it called steering. And there are many ways to do it. In most cases, if it's, for example, roaming technology, your roaming provider, your basically your supplier, your vendor of the SIM card will do it for you. Okay, and it's important piece of information. You have to double check because in most if your multi-IMSI/roaming vendor have this, because in most cases they will do it by their own costs and prices. So they will connect you usually, by default to the most shitty network. Be prepared. So you have to double check, and sometimes you can ask them to create your own steering list or to have SIM card that is not steered at all, which means it just connects to the best signal in the area. It's quite important both with multi-IMSI and with roaming SIM cards. You have to acknowledge it, you have to know about it, and once again, you have to double check it with your SIM card vendor. Okay. Question number 2, once again, how to manage satellite together cellular connectivity. Basically, it's a piece of advertisement here. Hey, use our software. With DROM, you can manage satellite and cellular all together. You can create pools of cellular and satellite connectivity. You can create bundles and basically everything in a single pane of glass to make your life easier and more effective. Once again, how to work simultaneously with multiple SIM cards. That's mostly a question about hardware. Like sometimes I have questions like I have 2 local SIM cards. Can I have higher speeds? How can I work with 2 SIM cards in one device? So there are basically quite a lot of different modems, quite a lot of different routers that support multiple SIM cards. And the most important, basically what you have to remember is that if you want 2 SIM cards to be online simultaneously, you need the device to have 2 modems, okay? Otherwise, it will not happen. So that's basically how it works. You don't have 2 modems, you cannot have 2 SIM cards simultaneously being online. iSIM. iSIM is basically roughly the same as eSIM, but the difference is that eSIM is a small microchip on your silicon, basically on your silicon plate in the device. iSIM is just basically a piece of a bigger chip that does a lot of things, and among the other things, it does authentication of cellular carriers. But it's roughly the same. standalone chip or chip that is part or already inside of a bigger chip. And basically a remote SIM provisioning protocol SGP32, as mentioned before, it's a way basically to send IMSI profile to a SIM card remotely. And by doing that, you can basically connect SIM card to a carrier of your choice with local profile, and you can do it remotely. That's all from my side, just in time. And yeah, if you guys have more questions, you can always contact me using the email. And if you have now more questions, please feel free to ask.
No.
Don't think we have more questions, guys. Thank you so much. Thank you, Birger, as well.
Hey, very welcome, and it's good to share some knowledge on connectivity. And if you've now learned a little bit on, if you optimize every part of that connectivity solution, you will have a kick-ass solution for your customer, and that's word to mouth. That's publicity for your company or your brand.
The
So
bottom line, I agree with you. The bottom line is that if you want the proper connectivity, you have to take into account 4 parameters, and you have to understand that every and each parameter has its own specialization. It's SIM cards, basically connectivity, it's hardware, it's connectivity management, and antennas. So all this chain of 4 topics, if you have a good setup, everything will work perfectly for you.
Yeah, and each week we see it go wrong.
Yeah, that's why the people still need us, and that's why our expertise is still valuable.
Yeah.
But basically, in every part of this Lego basically construction, you need the proper blocks, and you have to build everything correctly, so it all works in the right way. And that's why, you have experts in our company, in your company, in hardware companies, and that's why we are here.
Yeah,
indeed.
So thank you so much. And on behalf of Point partner D-Roam, thank you all for participating. And if you have any further questions or you'd like to get in touch, don't hesitate and send us an email and we'll reach out to you. Have a wonderful day. Bye-bye.
Okay.